Hi everyone. In this time I talk about vector space, some most important question. Okay, all question is very most important. So please you note down. First question. This question is examine. Okay, please you note down. EXAMINE. Examine if the set. Examine if the set S is a okay is a subspace subspace of R3. Okay, so S is equal to x, y, z belongs to R3, okay, and x equal to 0. So how to solve this problem? Very easy. First you condition you understand x equal to 0, okay. You remember x equal to 0, and here s is equal to given set x, y, z belongs to R cube, okay, and x is equal to 0. And next let alpha is equal to x, y, z, and beta is equal to, suppose beta is equal to x1 y1 z1, sorry, it is x1 y1 and z1, and it is beta is equal to x2 y2 and z2. Next alpha plus beta is equal to alpha plus beta is equal to alpha plus beta is equal to, it is x1 plus x2 y1 plus y2 and comma z1 plus z2, okay. And you remember alpha x1 y1 z1 and beta is equal to x2 y2 z2 belongs to S, okay, and x1 is equal to 0 and x2 is equal to 0. Next you understand. Next topic, it is alpha plus beta is equal to, it is x3, and next y3 and z3 belongs to S, okay. Next you understand because BECAUS, because x3 is equal to x1 plus x2 and is equal to x1 plus x2 value, put it this value 0 plus 0, 0 plus 0 is equal to 0. Next 2 number combination, it is first, and next second number condition, C belongs to R, alpha belongs to S. Now C alpha is equal to Cx, Cy and Cz, okay, means Cx1, Cy1 and Cz1, okay, and is equal to x x x4, y4 and z4 belongs to S. And next, as x4 is equal to Cx and Cx1, x4 is equal to Cx1 and is equal to x1 value 0 is equal to C into 0 is equal to 0. So therefore S is a vector, okay, subspace, subspace of R3, okay. So this is very simple question, okay. Next question, question number 2. In this video I provide many maths question, okay. Next question is examine if the set S is a subspace is a subspace, okay, of R3, okay. And next S is equal to x x y and z belongs to R3 and x equal to 1. Always remember, okay. So how to solve this problem? So first here S is equal to x, y and z belongs to R3 and x is equal to 1. Next let alpha is equal to x1, y1 and z1, okay, and beta is equal to x2, y2, z2 belongs to S. Next now x1 is equal to 1, x2 is equal to 1. Next alpha plus beta value, alpha plus beta is equal to x1 plus x2 and y1 plus y2 and z1 plus z2 not equals to S, not belongs to S, okay. Next, since alpha plus beta is equal to, it is S3 and it is y3 and it is z3 belongs to S. Next, because S3 is equal to x1 plus x2, we know that x1 is equal to 1 and x2 is equal to 1, it is 1 plus 1, so it is 2. You understand? Very easy, okay. Next, you understand, because it is not equals to 0, okay, and it is AC AC is not, AC is not a vector subspace. AC is not a vector subspace of R3, okay. So this two problem is very most important. Next I provide some many problem, okay. Next problem number 3, okay. Next, examine is the set S, okay. Suppose S is a subspace, is a subspace, okay, is a subspace of R3, it is R3, okay. So S is equal to x y z belongs to R3, okay, and x plus 2y minus z is equal to 0 first, and next equation 2x minus y, sorry, 2x minus y, 2x minus y plus z is equal to 0. This question is examine the set is a subspace of R3. So S is equal to x, y, z belongs to R3 and x plus 2y minus z is equal to 0 and 2x minus y plus z is equal to 0. Okay. Next here, how to solve this problem? Please note down here S is equal to x, y and z belongs to R3. Okay. R3 and x plus 2y minus z is equal to 0 and 2x minus y plus z is equal to 0. Okay. Next, let alpha is equal to x x1 and y1, x1, y1 and z1. Okay, and beta is equal to x2, y2 and z2. Next, to understand, next belongs to S. Okay, belongs to S. And next x1 plus 2y1 minus z. Okay, it is given question. Okay, x1 plus 2y1 minus z1 is equal to 0, and 2x1 minus y1 plus z1 is equal to 0. Okay, you understand? Next, x2 plus 2y2 minus z2 is equal to 0. Okay, and 2x2 minus y2 plus z2 is equal to 0. And next, first alpha plus beta is equal to x1 plus x2, comma, y1 plus y2, comma, z1 plus z2 is equal to this value, it is x3 comma y3 comma z3. Okay, next, now suppose you understand. Now, okay, now x3 plus 2y3 minus z3 is equal to x1 plus x2, and next plus 2 into y1 plus y2 and minus z1 plus z2 is equal to x1 plus 2y1 minus z1 plus x2 plus 2y2 minus z2. First to understand, it is x1 1, okay, x1 plus 2y1 minus z1. Next, x2 plus 2y2 minus z2. You understand? Next is equal to 0. Okay. Next, so alpha plus beta belongs to S. Okay, alpha plus beta belongs to X. Again, next, again 2x3. Okay, 2x3 minus of y3 plus z3. Okay, is equal to 0. This given equation, it is 2x minus y plus z is equal to 0. Okay, and you change this equation, it is 2x3 minus y3 plus z3 is equal to, okay, is equal to, sorry, is equal to is equal to, okay, is equal to 2x1 minus y1 plus z1 plus 2x2 minus y2 plus z2. This value, it is 0 plus 0 is equal to 0. So alpha plus beta belongs to S. So alpha plus beta belongs to S. Next, 2 number condition. 2, C belongs to R. C belongs to R. Okay, and alpha belongs to S. C belongs to R and alpha belongs to S. And therefore C alpha is equal to Cx1, Cy1 and Cz1 is equal to x4, y4 and z4. Change this topic. And next, you understand, x4 plus 2y4 minus z4 is equal to cx1 plus 2cy1 minus cz1. C common, x1 plus 2y1 minus z1 is equal to 0. Okay, and next 2x4 minus y4 plus z4. Okay, I repeat this topic. 2x4 minus y4 plus z4. Okay, it is 2 cx1 minus cy1 plus cz1, and next is equal to 2x1, it is 2x1 minus y1 minus plus z1, okay, is equal to 0. Okay, and you understand C belongs to C alpha belongs to S. C alpha belongs to S. C alpha belongs to S. Okay, and next, therefore S is S is a vector. S is a vector space of R3. Therefore S is a vector space of R3. Okay, very easy this question and answer. Okay, next you understand. Okay, this x plus 2y minus z is equal to 0, and 2x minus y plus z is equal to 0. Okay, and this 2x minus y plus z. Okay, change this equation, and this is C alpha belongs to S. C alpha belongs to S. Next question, question number 4. Okay, this question is examine if the set S is a subspace, okay, examine if the set S is a subspace of R 2 by 2, where, okay, where first, where, okay, so first is S is equal to A, B, C, D, and belongs to R 2 by 2. Okay, and therefore A plus B is equal to 0. And next, 2 number, S is equal to A, B, C, D belongs to R 2 by 2, and therefore determine value A, D, C, D equal to 0, and that is AD minus BC is equal to 0. And next, 1 minus 1, 0 1, and 0 1, and 0 0 1 0 0 1 1 belongs to R 2 by 2. And next, 2 minus 1 1 1 belongs to, okay, S. Next I talk about next question. Next I talk about this question is shows that next question shows that shows shows that the set S is a subspace. S is a subspace of the vector space okay, it is of the vector space okay, C 0 1, where first is S is equal to F belongs to C 0 1, okay, and therefore F 0 is equal to 0, and 2 S is equal to F belongs to C, okay, and 0 comma 1, and therefore f of 0 is equal to 0 and f of 1 is equal to 0, okay, and please you note this topic. C 0 comma 1, okay, is the set of wall continuous NIOUS continuous functions, okay, f from f from it is f from f such that 0 to 1 tends to R, okay. So first you note down this question answer here. S is equal to f of f belongs to C, it is 0 comma 1, okay, and therefore f 0 is equal to f of 0 is equal to 0, okay, and next let f1 f2 belongs to S, done. Next f1 0 is equal to 0 and f2 0 is equal to 0. Now f1 plus f2, now f1 plus f2 0 is equal to f1 0 plus f2 0 is equal to 0 plus 0 is equal to 0, and therefore f1 plus f2 belongs to S, therefore f1 plus f2 belongs to S, okay, and next let C belongs to R, therefore C belongs to R and f1 belongs to S, okay, and next CF1 0 is equal to CF1 0 is equal to C dot 0 is equal to 0. So CF1 belongs to S. S is a vector. S is a vector subspace. S is a vector subspace of C 0 comma 1 0 comma 1. Okay, very easy. Next I talk about next question. Okay, next question. Prove that intersection of two subspace subspace, okay, over a field F is a F is a field field F is a subspace is a subspace over the field field F, okay. Answer. This question is prove that intersections of two subspace, always remember, intersections and two subspace. Okay, two subspace over a field F is a field F is a subspace over the field F. Okay, so first you understand. Let, please you note down. I provide this question answer. Let W1 and W2 be B2 subspace, B2 subspace, okay, of a vector space of a VECTOR vector space of a vector space V, okay, of a vector space over V over the field F, okay. And next we want to prove W1 intersection W2, okay, is also vector subspace, okay, is also vector subspace of V, okay, of V over the over the field F, okay. Next we want to prove prove W1 intersection W2, okay. It is W1 intersection W2. We want to prove W1 intersection W2, okay. And next is also okay, vector space is also vector space of V, okay, over the field F. Next, first you understand case number 1, okay. If case number 1, if okay, case 1, okay, if W1 intersection W2 is equal to 5, okay, obviously W1 intersection W2, okay. Next, subspace of V over the field okay, F, V over the field F, okay. Next, case 2, okay, case 2, it is if W1 intersection W2 not equals to 5, okay. Next, let alpha beta belongs to W1 intersection W2, okay. And next one is alpha 1, okay, alpha comma beta belongs to W1 intersection W2, okay. And next, alpha comma beta belongs to W1 and alpha comma beta belongs to W2, implies that alpha plus beta belongs to W1 and alpha plus beta belongs to W2, okay. Implies that alpha plus beta belongs to W1 intersection W2, okay. And next, to it is alpha belongs to W1 union W2 and C belongs to F. Okay, and alpha belongs to W1 and alpha belongs to W2. Okay, and then C alpha belongs to W and C alpha belongs to W2, and next implies that C alpha belongs to W1 intersection W2. Okay, and therefore W1 intersection W2 is a subspace of V over the field F. Okay, W1 intersection W2 is a subspace of V of the field F. Okay, next you note this topic. Okay, note it is if W1 and W2 be two subspace W1 and W2 be two subspace of V over the field F. Okay, then W1 union W2 may or may not be subspace may not be subspace subspace of V over the field Okay, this question is if W1 and W2 be two subspace of V over the field F, then W1 union W2 may or may not be a subspace of V over the field. Okay, this answer it is given, and give an example. Okay, please this is one condition. Okay, if W1 and W2 be two subspace of V over the field F, and then W1 union W2 may or may not be subspace of V over the field. And next question. Okay, next question. This question is given an example to shows that union of okay two subspace union of union of two subspace space union of two subspace of V over the field Okay, answer. This question is give an examples to shows that union of two subspace of V over the field. Okay, sorry, this question is one mistake. This question is give an example to shows that union of two subspace subspace to subspace is not a subspace. Subspace is not a subspace. Okay, give an example to show that union of two subspace is not a subspace. Okay, and how to solve this problem? Next, let w1 is equal to x, y and z belongs to R3, and y is equal to 0 and z is equal to 0, and w2 is equal to x1, y1, z1. Okay, belongs to R3. Okay, and x is equal to 0 and z is equal to 0. Okay, and then clearly w1 union w2 is not a subspace, of R3. Okay, over R. W1 union W2 is not a subspace of R3 over R. Okay, and next, since since 1 0 0 belongs to W1 and 0 1 0, it is W2, and 1 0 0 plus 0 1 0 is equal to, it is 1 1 0 not belongs to W1 union W2. Okay, and next I talk about next question. Next example, it is next question. This question is next in R2 1 0 and 0 1 belongs to R2 are linearly independent. Since 0 1 0 plus 0 0 1 is equal to 0 comma 0 is equal to theta 0. Okay, it is C1 and it is C2 value. Okay, at 0. Okay, and next question, next some important question. Suppose you understand minus 3 1 comma 3. Okay, plus 1 into 3 comma 3 3 comma 0 is equal to 0 comma 0. It is minus 3 minus 9. Okay, plus 3 comma 9 is equal to 0 0. Okay, and next question, this question, next I talk about next question. This question is examine EXI MI and examine the set of vector, okay, it is, this vector is with 2 1 1 and 1 2 2 and 1 1 1. Okay, to answer, suppose you understand A is equal to 0, it is linearly dependent. Okay, and next, let C1 C2 C3 belongs to R, and C1 is equal to 2 1 1 plus C2 is equal to 1 2 2. Okay, and C3 is equal to 1 1 1 1 1 1, okay, is equal to 0 0 0. Next you understand 0 0 0, okay. Next 0 0 0, okay. And next it is C1 C1, okay, C1, sorry, it is 2C1. Let this is multiply 2C1 plus you multiply this C1 C2, okay, and this multiply it is C3, okay. And next it is C1 plus 2C2 plus C3, and next C1 plus 2C2 plus C3, okay, is equal to 0 0 0, okay. Next 2C1 plus C2 plus C3 is equal to 0, okay. And next C1 plus 2C2 plus C3 is equal to 0. This equation is equal to 0, this equation is equal to 0, and this equation is equal to 0. And next C1 plus 2C2 plus C3 is equal to 0, okay. And find out this answer. Next to understand 2C1 plus C2 plus C3 is equal to 0. And next C1 plus 2C2 plus C3 is equal to 0, okay. And let K is equal to C3. And next 2C1 plus C2 is equal to minus K, and C1 plus 2C2 is equal to minus K. And uh, and next 2C1 plus C2 is equal to minus K, and 2C1 plus 4C2 is equal to minus 2K. It is cancel out, okay. Next it is minus minus, it is plus, so minus 3C2 is equal to K, and C2 is equal to minus K by 3, C2 value, okay. Next C1 is equal to minus K plus 2 by 3K, and C1 is equal to minus K by 3, okay. And next C1 is equal to minus K by 3, and C2 is equal to minus K by 3, and C3 is equal to K. So okay, therefore C1, C2 and C3, C1, C2 and C3 is equal to 0. Next, so the set of vector, so the set of vector linearly dependent, it is LD, okay. So it is very simple equations and solving, okay. Next I talk about next question. नेक्स्ट क्वेश्चन में बोला गया है, नेक्स्ट क्वेश्चन एग्जामाइन, ये एक से एम आई, एग्जामाइन इफ द सेट ऑफ वेक्टर if the set of vector, okay, it is this vector is 1 2 3 0 and 2 3 0 1 and next 3 0 1 2 is Okay, answer. Okay, suppose you understand. Let I solve this problem. This question is examine if the set, okay, of vector 1 2 3 0 2 1 0 1 3 0 1 2. Okay, how to solve this problem? Let C1, C2 and C3 belongs to R. Okay, C1, C2 and C3 belongs to R. Okay, next C1, it is 1 2 3 0 plus C2 is equal to 2 3 0 1 and plus C3 is equal to this value 3 0 1 2. Okay, and next same process will solve this problem. It is C1 plus 2 C2 plus 3 C3 comma 2 C1 plus 3 C2 plus 0. Okay, means 0. Next comma C 3 C1 plus it is 0 and 3 1 মানে C3. Okay, next comma it is 0. Okay, this is 0 and C2 1 C2 plus 2 C3. Okay, this value. Okay, and next 2 C3 is equal to 0 0 0 is equal to 0 0 0 0. Okay, 0 0 0 0. Next you understand. Next C1 plus 2 C2 plus 3 C3 is equal to 0 and 2 C1 plus 3 C2 is equal to 0 and 3 C1 plus C3 is equal to 0 and next C2 plus 2 C3 is equal to 0. Okay, next you solve this problem. Next let C3 is equal to K. Okay, and it is C1 is equal to minus K by 3 and C2 is equal to minus 2K, means minus K by 3 minus 4K plus 3K is equal to 0 and where K is equal to 0. Okay, and therefore the system has only solution solutions when K is equal to 0. Okay, and therefore C1 is equal to 0 and C2 is equal to 0 and C3 is equal to 0. It is linearly independent. Okay, it is linearly independent. Next question. Three C1 plus K is equal to 0 and 3 C1 is equal to minus K, C1 is equal to minus K by 3. This is fine. Okay, and next question, it is find K belongs to R. So that the set that the set of vector linearly dependent, LD, linearly dependent this set is 1 to 1, okay, 1 to 1, and k 3 1 and 2 k 0, okay, 2k 0. How to solve this problem? Find k belongs to R so that the set of vector linearly dependent and 1 to 1 k3 1 and 2k 0. Okay, how to solve this problem? It is since the set since the set okay, since the set of vector, it is 1 to 1, okay, 1 to 1. Next, to understand. Next, it is the since the set of the vector 1 to 1, okay, and k 3 1, okay, k 3 1 and 2k 0 is linearly dependent, LD, linearly dependent, okay. And next we put it this matrix from it is determine value 1 to 1 and k 3 1 and 2k 0, 1 into 0 minus k minus 2 into 0 minus 2 plus 1 into minus k square minus 6, okay, is equal to minus k plus 4 minus minus plus 4 and minus k square minus 6, okay. And next it is k minus 4 plus k square, okay, k square is equal to plus 6, okay, it is minus, sorry, this is wrong process. I solved this problem. It is first one, it is k square, okay, this k square minus 6 and next minus 1, okay, this and this, it is k minus 4, k minus 4 is equal to 0 and next k square minus k minus 2 is equal to 0 and Sridhar Acharya formula, so k is equal to 1 plus minus root over 1 minus 4 into 1 into minus 2 by 2 into 1 is equal to 1 plus minus 3 by 2, means x is equal to minus b plus minus root over b square minus 4ac by 2a, okay. We apply this formula, okay, and k value, it is 1 plus 3 by 2 is equal to 4 by 2, means 2, and next 1 minus 3 by 2 is equal to minus 2 by 2 equal to minus 1, okay. So x value it is 2 comma minus 1, Okay, 2 or 1? 2 1. Sorry. 2 1. Next. Next I talk about next question. Next question is if option. Next question. नेक्स्ट क्वेश्चन में बोला गया है इज एस इज इक्वल टू 1 1 2 and 2 4. Okay, a basis okay of r2 okay. How to solve this problem? Okay, this question is s is equal to 1 2 2 4 a basis of r2. Okay, s is equal to 1 2 and 2 4 is not linearly independent, so so it so it cannot be so it uh, cannot be a basis of R2. Okay, next question. This is very little answer. Okay, next question. नेक्स्ट क्वेश्चन में बोला गया है इज एस इज इक्वल टू 1 2 okay and 2 1 okay. A basis of a basis BASIS a basis is of R2 okay. How to solve this problem? Next, let x comma y belongs to R2 and next now it is answered. Okay, and now it is xy is equal to c1 into 1 2 and plus c2 2 1 and next c1 plus 2 c1 comma 2 c1 plus c2, this multiply and this multiply this and this. Okay, and next and therefore x comma y is equal to it is x comma y. Next you understand, next suppose you understand c1 plus 2 c1 is equal to c1 plus 2 c2, sorry 2 c, it is c1 and it is c2, sorry it is c2 and it is c2 2c1 plus c2. Okay, and c1 plus 2c1 c2 is equal to x. Okay, and next 2c1 plus c2 is equal to y. Okay, and it is 3 c2 is equal to 2x minus y. Okay, and next c2 is equal to 2x minus y by 3 minus it is minus is equal to minus. Okay, and first equation c1 plus 2 c2 into 2 means 2c1 plus 4 c2. Okay, and 2c1 plus c2, it is 2x and it is y, minus minus minus, this cancel, and it is 3 c2 is equal to 2x minus y, and c2 is equal to 2x minus y by 3. Okay, and c1 is equal to c1 is equal to 2y minus x by 3. Okay, and next, and therefore x comma y is equal to 2y minus k by 3. Okay, it is 1 comma 2 plus 2x minus y by 3. Okay, it is 2 comma 1. So linearly span, ls mean linearly span, is equal to R2. So S is a basis. So S is a basis of R2. So S is a basis of R2. Next I talk about next question. Next question is find the dimension. Next question. Okay. Next question. It is find a basis. Find the dimension. Find the dimension. Find the dimension of the subspace of the subspace of R3. Okay, R3 defined FINED, defined by subspace S. Okay, subspace S of R3, and defined by S is equal to X, Y and Z belongs to R3. Okay, belongs to R3. So it is 2x plus y minus z. 2x plus y minus z is equal to 0. Okay, how to solve this problem? Very easy answer. Next, S is equal to x, y and z. X equal to x, y, and z belongs to R3. Okay, and 2x plus y minus z is equal to 0, is equal to, it is x comma y, it is, you find out this z value, it is 2x plus y minus z is equal to 0, and 2x plus y is equal to z. To put it this z value, okay, put it this z value, it is comma 2x plus y, okay, belongs to R3, okay, and x comma y belongs to R, okay, and is equal to x 1 0 2, 1 comma 0 comma 2 plus y into 0 1 1, and x comma y belongs to R. Okay, and next, let b is equal to 1 0 2 and 0 1 1. Okay, 0 1 1. Next, here b is linearly independent and span span b is equal to s. So therefore b is a basis. Therefore b is a basis of S. Okay, and dimension and therefore dimension S is equal to 2. Very easy. Next question. Next question. Find the dimension DIMENSION. Find the dimensions of the subspace SPACE of if R4. Okay, R4 of it R4 of R4 of R4. Okay, of R4. Okay, of R4 defined by S is equal to X, Y and Z W and belongs to R4, and X plus Y plus Z plus W is equal to 0. Okay, so how to solve this problem? This question is find the dimensions of the subspace of R4 defined by S is equal to X, Y, Z W belongs to R4 and X, Y, Z plus W is equal to 0. Okay, next answer. Okay, S is equal to S is equal to X comma Y comma Z comma W belongs to R4. It is R4. R4. Okay, and X plus Y plus Z plus W is equal to 0. Okay, and next is equal to X comma Y comma Z minus X, Y and Z means X plus Y plus Z. Okay, plus W is equal to 0. And next W value find out. It is W is equal to minus X minus Y minus Z. Put it this value. Okay, and next X, Y and Z belongs to R. Next is equal to X into 1 0 0 minus 1 plus Y into 0 1 0 and minus 1 plus Z into 0 0 1 and minus 1. Okay, and therefore X, Y, Z belongs to R. X, Y, Z belongs to R. And next let B is equal to 1 0 0 and minus 1. Okay, 1 0 0 and minus 1, and next 0 1 0 minus 1 and 0 0 1 and minus 1. Okay, next C1, it is 1 0 0 and minus 1 plus C2 0 1 0 minus 1 and plus C3 0 0 1 and minus 1 is equal to 0 0 0 0. Okay, and next C1 is equal to 0, C2 is equal to 0 and C3 is equal to 0. And so C1 C2 C3 minus C1 minus C2 minus C3 is equal to 0 0 0 0. It is linearly independent. Okay, and next C1 is equal to 0, C2 is equal to 0 and C3 is equal to 0. Okay, so B is B is linearly independent Li, and span B is equal to S, and so B is a B is a basis, B is a basis of S. Okay, and therefore dimension S is equal to 3. So dimension S is equal to 3. Okay, so next question. Next question. X, Y, Z. Next question. S is equal to X, Y, Z belongs to R3. Okay, and X plus Y plus Z, X plus 2Y, sorry, X plus 2Y, X plus 2Y is equal to Z, and 2X plus 3Z, 2X plus 3Z is equal to Y. Okay, and how to find this answer? Okay, S is equal to X, Y, Z belongs to R3, and X plus 2Y is equal to Z, and X plus 3Z is equal to Y. Okay, next answer here X, Y, Z, S is equal to X, Y, Z belongs to R3, and X plus 2Y is equal to Z, and 2X plus 3Z is equal to Y. Okay, next now NOW, now X plus 2Y minus Z. Okay, because X plus 2Y is equal to Z, and X plus 2Y minus Z is equal to 0. Okay, and next 2X plus 3Z is equal to Y, 2X minus Y plus 3Z is equal to 0. Okay, is equal to 0, and next 2X minus Y plus 3Z is equal to 0, and X by is equal to Y by is equal to Z by. X by means X component vanish. Next it is 6 minus plus 1. Okay, it is 6 minus 1. Okay, and next this is, it is 5 X by 5 is equal to Y by this cancels, mean 3 minus 3 minus, it is minus 5. Okay, and it is minus 5, means this and this. I repeat this topic. X plus 2Y minus Z is equal to 0, and 2X minus Y plus 3Z is equal to 0, and this is vanish. Okay, and 3 minus plus 2. Okay, Y means two x, and it is, oh sorry, it is minus plus 2 it is plus 2 plus 2 and 3 to the plus 3 minus 3 minus 2 minus 3, okay, plus minus 2 minus 3 means minus 5, and next it is this topic, it is minus 1 and minus 4 is equal to minus 5, okay, and next x is equal to y by minus 5 is equal to z by minus 5, z by minus 5, okay, and implies that x is equal to, oh, is equal to c, is equal to c, is equal to c, okay, and x is equal to 5c, and y is equal to minus 5c, and z is equal to minus 5c, and okay, therefore s is equal to 5c minus 5c and 5c minus 5c, such that c belongs to R, okay, c belongs to R is equal to 5c, it is 1 minus 1 and minus 1, okay, and such that c belongs to R, and next let 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 b is equal to 1 minus 1 and minus 1, okay, now b is OB VI OU SLY, b is obviously linearly independent, okay, and span SPAN, and span b is equal to s, okay, and b is a basis, b is a basis of s, b is a basis of s, so dimension s is equal to 1, okay, dimension s is equal to 1, okay, so thank you. Next I talk about next some important video and most important concept and most important question and answer.